Chapter 7.3. Today we're looking at special products of polynomials. So there are a few special patterns that arise when we multiply a couple of types of binomials specifically. All right, and so these three patterns that come across the top of this little table here are three patterns that are worth noting. This first one here is the sum of these perfect squares, a plus b squared. All right, so when we expand this and multiply it, the pattern that results is the first term squared, a squared, plus 2 times the product of a and b, plus the last term, b squared. And here's the reason why, and we'll demonstrate this using the box method. If we had a plus b times a plus b, then the result would be, the product here is a squared, and then this row and column would be 1ab, then this row and column would be another ab, and the final box would result in b squared. And that's where these three terms come up with. It is that first term squared, a squared, plus 2 of those ab's plus b squared. All right, the next one is just the same, except for now instead of a plus b, we have the difference of these perfect squares here, a minus b squared. Now that means we're going to change these symbols here from plus signs to minus signs, and that would make these two terms in the middle both negative, and that's how we get this resulting a squared first term minus 2ab plus b squared. All right, now the last one is the product of these things known as conjugates. Conjugates here are the same except for the signs between their last terms here. So we have a plus b being multiplied to a minus b. And an interesting thing happens here when we take this product. Once again, we end up with a times a, which is a squared. Then we have a times a positive b, which is positive ab. But then we have a times a negative b, which results in negative ab. And then finally we have negative b times positive b, which is negative b squared. So what happens now when we combine all of our like terms is that these two like terms here are opposites or additive inverses, and so they reduce to 0. And so you're just left with a squared minus b squared. All right, so those are the three patterns that we're looking at here, and let's jump into our examples. Example 1 says to expand and multiply to find the product. So we have 3x. Oh, let me get rid of that here. That looks like a negative 3x. Let's try that again. We have 3x plus 4 times 3x plus 4. That's what it means to expand. You're going to multiply 3x plus 4, that binomial, times 3x plus 4. And let's set this one up using the box method, just because it's good to get some practice with that method. And that results in 3x times 3x, which is 9x squared, 3x times 4, which is 12x. And then we have 3x times another 4 again there, that's 12x again. And then 4 times 4, which is a positive 16. So our product here is 9x squared plus 24x plus 16. So hopefully you can start to see that this is that first term squared, 9x squared, and that this is 2 times the product of 3x and 4, and then plus the last term squared. All right, let's try that same pattern, but now we're just going to see if we can jump right to the end result. We have the difference of these two squares, so when we expand it, we'll have 5x minus 2y times 5x minus 2y. Well, the result should be that first term squared, 25x squared. That should be minus 2 times their product, so that product should be 10xy. 2 times that would be 20xy. And then finally we have plus, and then that last term squared, so that's plus 4y squared. So that should be the end result. If you don't trust me, go ahead and either distribute it or create the box method and do the multiplication. All right, in our next two here we have multiplying, and if you'll notice that these are conjugates. So our conjugates, remember, have that middle term cancel out. They are additive inverses. So here we're just going to end up with the final result of that first term squared, which is t squared, minus the last term squared, which is 5 squared, which is 25. Same thing here for b. That's x squared minus 9. Now, this all leads to another interesting pattern when you're multiplying numbers that differ by the same amount to their nearest multiple of 10. So here's what I mean by that, right? This special product patterns helps us to find the product of 26 times 34 and other numbers as well. And the way we do that is 26 is really just 30 minus 4. And 34 is really just 30 plus 4. Well, these are conjugates, right? So if we do 26 times 34, it's the same thing as saying 30 minus 4 times 30 plus 4. So when we multiply these, we're going to just do our 30 squared, and 30 squared is 900, minus 4 squared, which is 16. So 900 minus 16 is 884. All right, pretty interesting. See if you can do one, a special product of, let's make this a little bit harder. How about we do 42 times 38? Go ahead and try that. Rewrite it just like we did here of 26 times 34 and see what you come up with for that special product.